All right, guys, here we go. Give everyone just kind of a few minutes to get in, just to make sure anybody who's here is here. Good to kind of see everybody so far. I have Carter, Morgan, Colton, Timmy, and Alex. If someone else is here, feel free to just type it in, just so I know you're kind of here hanging out. Um, so today I just wanted to review 23 homework with you, and then assign you the 23 take-home test. Okay, I'll assign you that test. Okay. And here's what I want you to do. I will send this in a message, but here's what I want you to do. Take that take-home test, okay, and read the directions, because you don't have to do quite all the problems. Just make sure you read the directions. Actually, let me go ahead and grab that so we can kind of go through it together. So here is that take-home test. It says there are 6 problems given below. All problems are to be done by yourself. No help is allowed. All problems are to be done algebraically without the calculator, except at the last step when calculator answers should be correct to 3 decimals. You must do problem number 1 and number 2 and any 2 of problems 3, 4, 5, and 6. Students who do a total of 5 or 6 problems, I'll give you some extra credit for those, for correct answers. All right. So we'll treat this as a test or project grade. And I know I said I wouldn't have you submit anything, but I am going to have you submit this so you can take a picture of it all and email it to me. There's a scanner app on the iPhone, and you can scan it. You can take a picture of it with your phone and like scan it as a PDF and send it to me. That's probably going to be the best route for you to do. Just download the scanner app on your phone, and just it'll literally let you take a picture of it, and then it'll scan it as a PDF and send it, and allow you to email it to anybody. So I want this. Hey, thanks, Ben. Good to see you, man. Let me look at my schedule real quick. So I want this done. I want it to me by Monday at 11:59 p.m. And I will send you a message with all this in. I want this emailed to me in PDF form, the take-home test PDF form, emailed to me by 11:59 Monday night, Monday the 23rd. Again, I'll type this all out in a message just so we can have some more clarity on that. Okay? Again, you're only working for the problems, but if you want to work extra for extra credit, that can help your grade. So again, Monday, 11:59 at night. Just make sure you email it to me in a PDF. Obviously, this with us being digital and online now, obviously this allows for a lot of cheating to occur, but I'm just going to encourage you, or encourage everybody, hey, try to figure it out. Okay, try to fight through it and figure it out yourself, and then just turn it in. I will have so much more respect for you, and I'll probably be a little bit more graceful on the grading compared to getting 7 tests that look exactly the same. Okay, so just want to put that out there. So this is due, the optimization take-home chapters 22 and 23 tests due to me Monday by 11:59. So part of that, what you want to make sure is that we're understanding the 23 homework. I felt like 23 was some of it was pretty challenging, and it's just going to be, there's a lot of algebra in this. I think it's more algebra than it is anything. Taking the derivatives are easy, but it's the algebra. This is more real world type stuff for you. So this is, if you've been saying, when are we ever going to apply this to the real world? I think this is pretty real world, because someone has to figure out revenue. And I know there's calculators out there for that, but who knows if a company hires you to do something with you having the ability to find the maximum revenue of a company for a certain thing. So All right, just jumping into this. Again, I don't know the best approach, whether it be to just kind of read through here, but I'm just going to go through each problem, kind of telling you where I went, and then you can ask me questions as we go through. So number one, the profit for an online company is given by this function, where A is the amount spent in hundreds of dollars on advertising. What amount of advertising yields the maximum profit? So maximum, when it's looking for a maximum, I know it's optimization. And what is that profit? So here's my function P, and I'm assuming that most of you have this most of the way done. If not, hey, I will tell you this. If you go, I'll just show you on my phone. If you go to, and that's that scanner app that I just used to upload some stuff because I hadn't gone back to the school. But if you go to Canvas, Canvas is, oh, there we go. Canvas. And like you go into AP Calc, you go to our class, and you go under Files. This homework is on there completed. So number 23, homework completed. So it's there with all the answers. Okay. So if you're like, man, I wish I could go back, or I wish I could see it. Here is all the homework that I've completed with the answers. All right. So that's there, along with number 22 homework, as well as the classwork for 23 as well. So I uploaded all that to the file so you can kind of see that. All right. And I use that scanner app for this, and it comes through. I mean, you're seeing it through a video camera, and you can see kind of how clear it is. So I mean, it's pretty clear on the thing. Mathway. Do I have Mathway? I actually don't know. I mean, I know that's our calculator. I don't know if I have Mathway, Colton. I mean, I have Photomath for sure. Okay, so all of this is online, but again, I'll just go through each one, and then I'll take any questions. So again, here's our function, and we have the same variables, so we just derive it, negative 3a squared plus 60a. Set it equal to 0 and solve. We get a is 0, a is 20. So the amount spent for ads is actually $2,000 because a is the amount spent in hundreds of dollars. So 20 hundredths would be 2,000. And then what would be the profit? Putting 20 back into a. Once you solve that, you get 29,000. And the question said, explain why if they spend more than a, their profit may not be as great. Obviously, if they spend more than $2,000 in ads, some of the ad money may be wasted. Thumbs up or questions on one. Give me a thumbs up if you're good, or a question if you have a question about number one. I got one person that's good. Everybody, are you good? Cool. There you go. Good. Morgan's good. Anybody else? Okay. All right. Assuming we're good, let's jump down to number 2. And again, if you need to see it, just go to the files or just rewatch it later and pause it. So looking at number 2, a moving company calculates charges for delivery based on the average velocity V the truck travels, as well as time it takes to make the trip. The fuel cost is represented by this right here, and the driver's cost is represented by this. Find the velocity V that the truck should travel in order to minimize optimization, the cost of a 120-mile trip. Complete the chart. I always find the chart a little bit easier to go with first. So starting with, if the velocity is 10, that T, if they're going at 10 miles per hour, it's going to take them for a 120-mile trip. It's going to take them 12 hours. And then the fuel cost per hour would just be putting 10 into this and getting $1.67 per hour. therefore making the fuel cost $20. Okay. And then our driver costs would just be plugging that in there. 60 times the $12 per hour would give me $720 for a total trip cost, a fuel cost and driver cost to be $740. If they drove 20, the average velocity was 20, they would make the trip in 6 hours. 6, if you plug 20 into this, you're going to get 667. The fuel cost for 6 hours is going to be $40. I think it's 40.0 something, but 40 is fine. Driver cost for 6 hours, 6 times 60 is 360. And then the total cost is 400. If they drive 40 miles per hour, they would make the trip in 3 hours. Their fuel costs would just be plugging, again, 40 into the V. 40 squared divided by 60 would give us the 26.67. The fuel cost, 26.7 times what we have there, and that times the number of hours, that would give us 80. And then the driver cost would be the time times the 60, which is 180, giving us 260. So that is the table. Now we have to create the formula. Now, a lot of this stuff, a lot applies to some outside knowledge. For instance, distance equals rate, your speed times the time. All right. The rate times time. So therefore, I knew that we were going to have this 1 over 60. Okay. So this is your fuel cost right here. I knew it'd be 1 over 60 times V squared over T. But I went ahead and broke it down, and I found V because I can't have T and V in here. But since I know this is kind of like my secondary equation, right? This is my secondary. So I know that V, when I divide both sides by T, I get 120 over T. And then I plug that into this up here. And then that would take me to, if I take the 60 out, like I'm saying, like 1 over 60 times V squared over 1. And then I plug that 120 over T into this, 1 over 60 times 120 over T squared over 1. And then I simplify, and then I bring this here. That's the total fuel cost in terms of T. And then the driver cost. So cost is equal to the fuel cost plus the driver cost. So this is our fuel cost. This is our driver's cost. Once you square that, and have this T with that as well. Once you have that, because the fuel cost is this times the number of hours, that will simplify out to be 240 over T. I think the most important thing for you to know there is that distance equals rate times time. For your secondary equation, to find what V is to take care of V. And then again, it's all algebra from here. This is all algebra. And then from here, we're ready to derive. So jump over here to the derivative. That's like 240t to the negative 1. So negative 240 over t squared plus 60. And then from there, just multiply everything times t squared, the 0, this, and that. It'll take out it from there to put it on that. 0 times anything is 0. And then just subtract it, take care of your negatives. T squared equals 4. T is equal to 2 hours. So in order to minimize the cost, the velocity needs to be 60 miles per hour with a cost of $240. Give me questions or questions on that, or thumbs up. Either one. Good Ian. Good Alex. Good Morgan. Good Timmy. Good Ben. Good Carter. Good Colton. Okay, jumping here to number 3. Normally, a pear tree will produce 30 bushels of pear per tree when 20 or fewer pears are planted per acre. However, for each additional pear tree above 20 trees per acre, the yield per tree will fall by 1 bushel per year. So if you plant 20 trees, you're going to get 30 bushels. Okay? But for every tree you plant, every extra tree you plant, you're going to lose a bushel. Okay? For every extra tree over 20 you plant, you'd lose a bushel. So how many trees should be planted per acre to maximize the total yield? If confused, make a chart like, not Mike, like the apartment housing classwork problem. So remember the apartment one that we did about the apartments in Chicago. So I went ahead and made this because I honestly think, guys, the table is, again, we're all different, but I think the table is valuable because it helps you see the problem a little bit better. So if I plant 20 trees, I'm going to get 30 bushels. But it said, however, for each additional pear tree above 20 trees per acre, the yield per tree will fall by 1 bushel per year. So if I add a tree, that means I've planted 21 trees and I'm losing a bushel. Okay? If I plant 2 trees above the 20, I've now planted 22 trees and I have 28 bushels. So from there, I have to use algebra to create what's happening here. So X represents the number of added trees. Trees planted would then just be 20 plus the number of trees we have. And the bushels would represent 30 minus the number of trees we have. B then equals the trees planted. Again, think about this. 20 times 30 is 600. So your maximum yield will be how many ever trees you have times the number of bushels that it creates. So you just multiply those two. We do some FOIL. We get 600 plus 10x minus x squared. We take the derivative, negative 2x plus 10. We get x equals 5. So that's 25 trees maximizes a yield of 625. And if we would have kept going with the table, you could have even looked at this with the table. And again, if you work this all table, that's what we call logic, and over here is what we call algebraic. Now, on your take-home test, it literally says all problems are to be done algebraically. So we got to see this. The table can help, but we have to see it solved algebraically. Makes you think a little bit more. Thumbs up or questions for number 3. Good, Colton. Good, Alex. Good, Ian. Good, Ben. Good, Timmy. Cool beans, guys. Looking at number 4. A national muffler shop charges $120 to replace a muffler. At this rate, the company replaces 75,000 mufflers per week. For each additional $5 the company charges, it tends to lose 2,000 customers a week. How much should the company charge in order to maximize their revenue? If confused, make a chart like the apartment housing classwork problem. So again, I start with the chart just to kind of see what I'm doing here. So if there's no extra charge, they're charging $120 and they're selling $75,000 muffler jobs and their revenue is $9 million. If they add on an extra, if they take off, if they add $5, which is adding on one extra, they now charge 125. But now they've that doesn't even it doesn't sound like naturally right. Like, oh, we're going to charge $5 extra, but then we're going to lose 2,000 customers. That doesn't sound logically like it makes sense. But obviously, here you would make more money if you do two. If you double it, you're now charging them 130. So now you've lost a total of 4,000 customers by adding $10. But that's, again, it still increases at 9.23 million. We want to find how to maximize this cost by adjusting the charge, and obviously our customers lost. So X represents the number of the extra amount that we take off each time we increase it. So then this would represent the original 120 plus 5, because that's what we're taking off, times the number of times we take it off. 5x, and then this would represent 75,000 minus the 2,000 x that were taken off. Again, more algebra here than calculus. Jumping over here, our revenue is equal to right here. FOIL this first outer inner last. You're gonna get some big numbers. 9 million plus 135,000 x minus 10,000 x squared. Derive it. Solve for x. X is 6.75. It would be, in order to maximize the revenue, they would need to charge $153.75, making their revenue come to $9.4 million. Anybody get that right? Good, Colton. Good, Timmy. Good, Alex. Okay. Any questions? Good, Morgan. Look at you, girl. Look at us. Yeah, you guys are all saying yes. You're like, I got it right now. Very good, guys. All right, jumping to the backside, number 5. Okay. A car dealership sells a popular car at $40,000 and typically sells 80 of them a month. For every $750 that they reduce the price, they sell 3 more cars. What price will maximize their revenue? If confused, make a chart like the apartment housing classwork problem. So, again, if they don't decrease the price at all, they charge $40,000, they sell 80 cars, $3.2 million in revenue. If they decrease it by one time, they now charge $39,250. They're selling 83 cars, and now they're at $3.25 million. So from here, we can create some equations to represent the cost in the cars. X is going to represent how many times we decrease it. So then for our cost, it's our original 40,000 minus 750. That's a 750 there. 750x, sorry. Minus 750x, because you're taking off 750 for how many times you decrease it. Our cars would just be original amount plus 3 times the number of times we decrease, because it goes up 3 each time. And then from there, we just multiply these two together in order to find our revenue. So multiply those two together. FOIL it out. 3.2 million. Again, some pretty large numbers here. And then derive it here. 60,000 minus 4,500x. And then you should get x to be about 13.3. So you should charge customers $30,250 based on our cost function. We should charge them $30,000, and our revenue will be $3.6 million. My question to you, I mean, this seems like a pretty realistic problem. Does this really happen in car dealerships? What do y'all think? Is this stuff really happening? Okay, Colton says, yes, it happens, but not at a fixed rate. Okay. Yes, just more variables. Right, very good. So Ben says, yeah, there's some more variables involved. Alex has said it wouldn't be this precise because competition makes people lower their prices. Yeah. Yeah, that's right. Yeah, so there's going to be, and most likely, um, this car dealerships probably obviously hired some outside firm to kind of show them, hey, if you're selling cars at this cost, it's going to give you your maximum revenue. But like you all said, I mean, I don't know if there's a car that really sells like that. That it's like, hey, we can sell this number of cars. I'm sure there are cars out there like that, but just kind of intriguing. It is. This does take that realistic approach, but I would agree with Colton, and maybe not necessarily a fixed rate like this, where it's just automatic rate. Yeah, Ben, that's what I was thinking. Like Honda Civic or Toyota Camry. So shout out for Alex for getting to the Akron's Honor Program. That doesn't surprise me. Big shout out to you, Alex. Congratulations, man. Timmy's our hype guy in the chat box. See, that's the thing. I would do Zoom, but you all be firing. You guys would be shooting guns the whole time. I really would. I wouldn't mind to do Zoom, but I know you guys would be going crazy the whole time. No, I'm just joking. Yeah, big props to you, Alex. Okay. Looking at any questions on 5. Can we move on? Thumbs up, smiley face. Yeah. Alex speaks for everybody. He said, we are good. All right, going to number 6. At a supermarket, a 2-liter Pepsi costs $1.49, and in a week the store sells 2,000 bottles. For every 5 cents that the market reduces the price, it will sell 150 more bottles in a week. If the cost to market a bottle of Pepsi is 25 cents, at what price should it sell Pepsi to maximize the profit? Okay. So this is a little bit different approach than what we've seen in the last couple problems, but kind of the same approach. So if there's no decreases, they're charging $1.49 for a 2-liter. They're selling 2,000. Now we can easily find the revenue of that. The revenue would just be the charge, how many you sold times how much you sold it for. But the issue is it's costing them 25 cents to market or to advertise for the Pepsi. So there's some cost involved. And that's where you would need to know this. This where you would know this right here. And again, that's that outside thing that you know. You know, distance is rate times time, the speed, whatever. And then as well as profit is revenue minus the cost. To answer your question, Morgan, I do not drink carbonated beverages. I don't do any carbonation at all. Colton, my wife is addicted to Coca-Cola as well. The ones from McDonald's. She hasn't had one in like 2 days because I keep telling her that we're staying in quarantine. and she's about to like rip the house apart. The last drink, and I probably wouldn't have done. I probably wouldn't have done the. I probably wouldn't do Coke or Pepsi. That's not me. The last soda I had was December 31st of 2012, and I drank a Mountain Dew at Backyard Burgers. I don't know if you guys ever go. It was in Madisonville, but in Destin, Florida, there's a Backyard Burgers. If you're ever down there, try it out. Good stuff. But um, the reason I was reading a book at the time, and Tim Tebow said his parents used to give him $100 a year if he'd go without drinking soda. It was actually Tim Tebow's book that I was reading. And then my son was about to be born that spring, so I thought, you know what, I need to be a good example, not drink Coke. So yeah, now Ben, I'm from the South, man. If you don't drink tea, they'll kick you out of the South. So yeah, I do drink some tea. So that's why I'm still fat, because I drink too much sweet tea. If I gave that up, well, I'd probably still be fat just because I enjoy eating. But oh yeah, is there something besides sweet tea that people drink? Come on now, Ben, you know better than this. Especially putting this in the chat box like that, Ben. Come on, my guy. All right, very good, Morgan, at throwing us off for like 5 minutes. You've done phenomenal work. So going back to the problem. Back up here to our profit equals revenue minus cost. So again, if we decrease it one time, our charge, yeah. It'd be like this the whole time. It'd just be going crazy the whole time, Carter. But I guess you can. I assume you can mute and do all that. Actually, I don't need to. I don't want to lecture on it or how to do it or anything like that. So let's finish this up. So X represents the number of decreases. My charge, okay, is 149. And I can just take the decimal out to just keep that like that. So 149 minus 5X. And that will always give me my amount. And then 2,000 plus 150X, how many times we decrease it for our sold. So our profit is our revenue. Now, again, our revenue is this times this, okay? That's what we've been doing on these last couple of problems. It's the charge times the sold. That's our revenue. But we have to subtract it from our cost, okay? Our cost here is it costs us $25 for what we're selling, okay? So you take your revenue minus 25 cents is what it's costing us to do it. So everything we sell, we're going to have to multiply what we sell times 25 and subtract it from our revenue to find our profit. Okay. From here, you get into some nasty numbers, but FOIL this 298,000 minus 10,000x plus 2,350x, yada, yada, yada. Derive that. That's gone. That lose your x, negative 1,500x, and then lose your x there. And then add 1,500x to both sides. You get 1,500x, and then just combine all of that, and you get 8,600. You find that to be x equals 5.733. Put that in our charge factor because we're trying to figure out how much to charge. What price should it sell Pepsi to maximize their profit? So when x is 5.733, we'll find our max, and that's at $1.20. Okay, questions? Or I'm good on that. Thank you, Alex. Thank you, Ben. Good, Cole. Good, Morgan. Okay. Seeing no questions, let's go to the next one, number 7. So a real estate office handles 75 apartment units. When the rent is $1,080 a month, all units are occupied. However, on average, for each $50 increase in monthly rent, 2 units become vacant. Each occupied unit requires an average of $72 a month for service and repairs, and each unoccupied unit requires $150 a month to keep minimum heat in the unit. What rent should be charged to realize the most profit? So start. I just find it easy to start with just, hey, what are we dealing with here? So when we have no increase, we have 75 apartments rented, and that is our rent here. Okay, we know this times this would give us our revenue. But if we increase it by one time, that takes us to 73 apartments, but our rent increases to $1,130. So this, I just do 2 of them or 3 sometimes just to kind of get my algebraic representation here. So X represents any increases. The apartment rented will be 75 minus 2 because it goes down 2 every time that goes up. And 1,080 plus 50X because it's times 50 every time this goes up. So profit is equal to revenue minus the cost. So profit is equal to our revenue, this 75 minus 2X times 1,080 plus 50X minus all the cost that's involved. And so you can have more than one cost. Up here we just had one cost. This is the ad cost. Here we have 2 costs. So we have a cost for the apartments. So it costs $72 a month for occupied units. So how many ever apartments we have are numbers of apartments, and the number of apartments is represented times that are occupied is represented by this right here. So looking at this would give us how much it would cost for occupied, and then it's $150 a month for those that are not unoccupied. And it goes down 2 every time X increases. So I say 150 times 2X. No questions on that. We just do the math. FOIL it out, distribute, multiply that, then derive everything. Takes us to this. 200x equals 1434. Once you move that 200x over and add that, you get 7.17. Type that into what our rent should be because it's asking what should rent be. And to maximize our most profit, or to get our most profit, we need to charge $1438.50. Questions or, hey, I'm good on this? Colton, you're Ben, Carter, Morgan, Ian. Okay, look at number 8. A power station is on one side of a river that is half a mile wide. The river is a half a mile wide, and a factory is 6 miles downstream on the other side. It costs $60,000 per mile to run power lines over land, and $80,000 per mile to run them underwater. Find the most economical path to lay transmission lines from the station to the factory. Okay. So again, our cost when we're looking for cost, it's just basically how much is it going to be, how much is the cost going to be on water and under land, those two numbers added together. All right. So in order to find a maximum or a minimum of that, we set the cost function here, or formula we could call it, and we find out what's what. Okay. So this first one is going to represent underwater. So this 8, I just took our zeros out. 8 times, okay, or 80 times whatever this hypotenuse is. If you want to find that hypotenuse, you would just simply say x squared, Pythagorean theorem, x squared plus b squared, 0.5 squared is 0.25, equals c squared. So again, that would look like this. X squared plus 0.5 squared equals c squared. That's x squared is plus 0.25 equals c squared. Sorry about that. And then I just do the square root of both sides. C is then equal to radical x squared plus 0.25. So that's my function, right? This inside this right here is my function for underwater. So I just multiply that times 80,000 or 8. You can use 80,000 if you're more comfortable with using the numbers. That's no worries. But I'm just taking the zeros out. So that would represent 80,000, and then plus the on land would just simply be 6 minus x times the 60,000. So 6 minus x represents on land or over land. And then we multiply whatever that value is times 60 to find our cost there. We just add those two together to find our total cost. From here, I have the same variable, so then I would just derive it. From here, you would get this right here, 8x over radical x squared plus 0.25. Minus, if you distribute, you get 36 minus 6x, so just minus 6. Add 6 to both sides, multiply both sides by the denominator, and we get it to this, and then equals 8x, and then square both sides. That takes us to 36, and then we lose basically the square and the square root cancel, and we're left with x squared plus 0.25 equals 64x squared. Divide both sides by 36. That takes me to x squared plus 1/4. I just made it a fraction, equals, and then that would be 16 over 9x squared. When I subtract x squared from both sides, that's saying 16 over 9x squared minus 1x squared, or I can just say minus 9 over 9x squared. And then I get, nice fraction problem here, then I get 7 over 9x squared equals 1/4. Divide both sides by 7/9 to get x squared is equal to, technically speaking, that wouldn't be there just yet. X squared is equal to 9 over radical 28. And then square root both sides, and you get the square root of 9 over 28. And then x is equal to 0.567. So that's what your x represents. So subtract, say, 6 minus that. And that means you need to lay the power line to 5.433 miles from the factory and then go underwater. And then that would bring my minimum cost. Once I plug that number back in up here, that would take my minimum cost to $386,458. Questions? Good, Colton. Questions? I'm good. Anybody? Good, Alex. Good, Tammy. Good, Morgan. Good, Ben. Good, Carter. Good, Ian. Okay. Now going to the next page. Last page. 3 problems left. Almost done, guys. We'll get you out of here. All right. This is where the fun starts. Mr. Schmidt is building a symmetrical deck of constant width on the corner of his house, as shown to the figure to the right. Fencing is placed on the edges of the deck with no fence needed against the house. Fences perpendicular to the house cost $5 a foot, while parallel to the house will cost $3 a foot. If Mr. Schmidt wants a deck with an area of 200 feet squared, what is the minimum cost to build the deck? All right. So we know that our cost, we know we have 2x's, or we can say 2 5x's, we could say there and get 10x, or 5 times 2x is 10x. And then 2 3y's, or 3 times 2y would be 6y as well. So a couple of different ways you could look at that. So that's 10x, so our cost is 10x plus 6y. We run into a problem there because we have 2 variables, so I need to create a secondary equation. Okay, now this is where it gets a little bit funky, but I think I'm going to try to explain this slow, so I'm making sure we're all here, okay, on this. So here's the way I look at this secondary equation. I know that I need the area to be 200. We're not dealing with a square here, so we just can't say x times y. So I broke it down into 2 rectangles, okay? So I have this rectangle right here, okay? That to me is going to represent x times y. X times y. And again, so it's like looking like at 2 things, it's doing this. I'm looking at it almost like that, okay? But the difference is we don't know what this is right here. We don't know that length, okay? So here's what we say. We say for this one over here, we need the x distance for sure. And we need the y. So I say x times the y, this y, but minus this x down here. So this right here, this rectangle right here will give me x times y. This rectangle right here will give me, that's x times y too, but I don't need the x here. So I say x times y minus x. And that's where I'm coming up with this right here, the area equaling 200. Again, I'm really taking the area of both tall rectangles. I'm really taking the area of that and that. But I'm taking care of this area with this rectangle. And I'm taking care of that area right here. But I'm saying I don't need this x right there. So I'm saying x times y, but minus the x. Did I explain that okay? Are you all seeing that? It's not your typical area type problem. All right. So then from there, I just distribute this xy plus xy minus x squared equals 200. That would go to 2xy minus x squared equals 200. And then add x squared to both sides and divide by 2x, y equals x squared plus 200 over 2x. We then put this in for y. Put this in for y. And you can go ahead and distribute that. 6x squared and 1200 over 2x. Well, 6x squared over 2x would just take us to 3x. And 1200 over 2x would take us to 600 over x. So just doing some mental math there. I then derive it. 10x and 3x is 13x. So that would be 13 minus, again, if that was 600x to the negative 1, the negative goes down, the x squared drops. So minus 600 over x squared. Subtract 13, get rid of your negatives, and I'm getting x to be 6.793. I plug that back into this x to find my y of 18.116 feet. I then plug this x and this y back into my cost function in order to find my cost at $176.63. Thumbs up or questions on A? Good, Colton. Good, Alex. Good, Morgan. Okay. Going over to B now. So B, looking at B, sorry about that. So it's saying if Mr. Schmidt wants to spend no more than $250, what is the maximum area of the deck? So again, maximum tells me optimization. The area of this deck, we've already found that to be xy plus x times y minus x. And then, of course, we have a y here, so I have a secondary equation. So what restriction do we have here? The restriction we had over here was the area had to be 200. The restriction we have here is that the cost can be no more than $250. So then, of course, just subtract the 10x and then divide by 6, and I get 250 minus 10x over 6. I then plug that into, I went ahead and distributed that out and got to this line right here for this. So distribute, and then that simplifies to that. Plug a y in right here. Now, I did this on a separate sheet of paper, guys. I did all this math on a separate sheet of paper because it gets pretty crazy. And in the words that most students tell me is like, oh, I lost that sheet of paper. So if I'm right here, in this, basically plug that in, multiply that and that. That gives me 500x minus 10x squared over 6. And then 2 will simplify all that. And that takes me to this, 250x minus 10x squared over 3 minus x squared. And then I basically just make this. I need to get the denominator the same in order to get these two together. So I have to multiply this side all by 3. And that will take me actually, and I did it right here. So 250 minus 10x squared minus over 3 minus x squared. Multiply the top and bottom over here times 3 in order to get like, and over here you just multiply times 1, which doesn't change anything. So here you'd have 3x squared over 3, and then you just combine this and this since you have like decimals, taking us to this 250x minus 13x squared over 3. If you take the derivative of that, which you all can do, you're going to get 1/3 times the quantity of 250 minus 26x. From there, I would divide both sides by 1/3. and then add 26x to both sides and get 250. X is equal to 9.615 feet. Plug that into my Y, 25.641 feet. And then from there, I can find my area by plugging these values back into this right here. 400.64 feet. Questions, thumbs up, whatever. Any questions at all? Questions, thumbs up, good. I'm good. Y'all still with me? Cool. Thanks, Alex. Okay. Okay. Going to 10. A nursery is planting a garden consisting of a circular pool surrounded by flowers as shown to the figure on the right. The 400 feet of brickwork separating the pool, this right here, separating the pool from the flowers, from the surrounding pavement, and the flowers from the surrounding pavement, is being donated and doesn't figure in the cost. If the cost of the water area is $15 per square feet, and the cost of the flower area is $5 per square feet, what are the dimensions that will allow them to build the garden for the cheapest price, and what is that price? Okay, so the cost is going to be the area of the water plus the area of the flowers. All right, so let's explain where this is coming from. The area of the water, area is pi r squared of a circle. So pi r squared, the area times 15. That gives me my water. That's pretty simple. Take $15 and multiply it times your area. That'll give you your total cost for that water area. The flower is this right here, okay? It's the outside, but we don't need the area of the inside, okay? So that's where we come with this. Again, it's pi r squared. So it's technically 5. That's what it costs per square feet to build it. 5 pi, and then times r squared. But our r here, it's actually our big R, okay? Big R minus little r squared. So r squared minus this r will give me the area of just the flower bed portion of this pool. Okay. Now that creates a secondary equation because there's a difference in big R and little r. Okay. So that's two different variables here that we have. But it gave us a restriction up here. It tells us something up here in the word problem that kind of helps us out. And it's this, that it should be equaling the circumference. Ben says big R represents the radius of the flowers. So big R represents the radius of the big circle, Ben. So in order to find the area of the flowers, this part right here, we have to say big R minus this R, and that will represent the area of just the flowers. You follow me in that, Ben? Yeah, cool. So here is what we know about circumference, though. Okay, it tells us the 400 feet of brickwork separating the pull from the flowers. So this right here, this literally line, this line right here, and the flowers here, okay, is equal to 400. Okay. So our circumference of the big circle should be 2 pi big R. Okay. Because circumference of a circle is 2 pi R. And then the circumference of the little circle should be 2 pi little r. And those two together are equaling 400. Based on what it gave us right here. The 400 feet of brickwork separating the pool from the flowers and the flowers from the surrounding pavement will be donated and doesn't figure in the cost. Okay. So then we solve for big R here by subtracting 2 pi r and then dividing by 2 pi. And again, I didn't have the room to do it here. I did it on a separate sheet. But what you could do is once you simplify that out, you get big R is equal to 200 over pi minus r. All right. So then we come here and we now plug this formula, R equals 200 over pi minus R, into this R right here. Big R, R right here. So big R, pulling this and putting it right here. So 15 pi R squared plus 5 pi, and then times 200 over pi minus R squared minus R squared. So then let's take the derivative of this. The squared, 2 times 15 is 30 pi r plus 5 pi. 5 pi is going to stay on the outside here, okay, because it's attached with all this. So we can derive what's on the inside, though. So that would drop that 2 down. That'd be 2 times 200 over pi minus r times the inside of the derivative. This is a constant, so that would just be minus 1. And then minus r, the derivative of r squared is minus 2r. I then do some math in here and get multiply that 2 times 200, which is 400, and then multiply all that, change all the signs in there to negative. So that makes that negative 400 over pi, and then it makes that right there, because we got to distribute the 2 to the r as well. It makes it plus 2r, and then minus 2r. Okay, from there, this would cancel, and then 5 times negative 4,000 would be negative 2,000. Those pi's cancel, and then I'm just left with subtract 30r from both sides. That would remove both negatives. 30 pi r equals 2,000. So little r is equal to 2,000 over 30 pi. Okay, and then from here, we would just plug that in. So inside radius, the inside radius here, 200 over 30 pi is equal to 21.221 feet. We then plug this right here into this over here, and we get the outside radius of r to be 42.441 feet. I then plug both of these numbers into my cost to get a cost of $42,441.32. Questions on number 10? Questions, or give me a thumbs up if you're good. You're seeing all that. Cool, cool, cool. All right, last problem, guys. Almost done. Just an hour and 15 minutes in, so not bad. A hallway that is 4 feet wide meets another hallway that is 6 feet wide at a right angle as shown in the figure below. What is the length of the longest ladder that can be carried horizontally around the corner if it's held parallel to the ground? Hint, express the length of a ladder in terms of angle theta. Okay. So here we go. Here's what we know. We know that this ladder right here, okay, this ladder right here, we're trying to see what's the length of it, what's the longest it could be in order for it to fit around this corner. So I know that the length of this ladder is equal to the length of the right side and the left side. So we can call that length 1 and length 2. So I'll call this right here length 1. And I'll call this other side here length 2. So if I am looking at this angle right here, guys, I know it may be kind of hard to see, but if I'm looking at this angle right here, this theta angle, I know that it gives me the opposite over the hypotenuse. Opposite over hypotenuse. I have to figure out what this length is right here and what this length is right here. Well, to do that, I'm going to have to use some trig functions. So what is opposite over hypotenuse? In order to find this, that would be sine. So over here, we have, these are kind of like our secondary equations. Sine theta is equal to 4 over length 1. That's opposite over hypotenuse. And if I simplify that down, because I'm trying to find what L1 is here, I multiply both sides by L1 divided by sine, I get length 1 is equal to 4 over sine theta. Same thing with cosine. Cosine, it's 6 over length 2 here. That would be adjacent over hypotenuse. I don't know this other angle, so I can't use it. So I'm using I'm using the sides that it's giving me. So this is adjacent over hypotenuse, which is cosine. So then I say cosine theta is equal to 6, the adjacent of the theta, over length 2 or side 2. So I'm not worried about, because I know you may be saying, well, how do we know to use those two? Because I don't care about that and I don't care about that. I only care about these two, and I need to find what length 2 and length 1 is. So then I multiply both sides by L2, divide by cosine, and get length 2 to be equal to 6 over cosine theta. So then I plug both of these values into these length 1 and length 2, because the ladder is going to be this length and this length combined. Then from there, I can derive. I just take the derivative of this, and again, you guys could go on the side and find the derivative of that. I kind of started the derivative right here with this. So like 4 over sine plus 6 over cosine low times derivative of high minus high times derivative of the low over low. So that gave me 4 cosine theta over sine squared theta. And then again, if I did it for this as well, 6 sine theta over, if I take this derivative, I get 6 sine theta over cosine squared theta. Then from there, I cannot add these because they don't have like denominators. So if you remember from algebra, multiply the first equation by the denominator in the second, multiply the second by the denominator of the first. Some people call this the butterfly method. This times that, that times that. Looking something like this right here. And technically we put like kind of parentheses around that to show that multiplication. From there, you get negative 4 cosine cubed theta plus 6 sine cubed theta all over sine squared sine squared theta cosine squared theta. Luckily for us, since this is equal to 0, we multiply both sides by this denominator, and then we bring that up here to, and then add 4 cosine theta, 4 cosine cubed theta to both sides. You get 4 cosine cubed theta is equal to 6 sine cubed theta. And then I know something about tangent. Tangent is sine over cosine. So I divide both sides by cosine and then get 6 tangent cube theta and then divide both sides by 6. 4 over 6 is 2/3. And then tangent cubed theta of 2/3. Theta would then be equal to 0.718. From there, I plug that number into my thetas here. And I get 6.08 here, 7.97 feet here for a total distance of, for a total ladder length of 14.047 feet. Questions? Talk to me. Cool. Okay. This is in your files on Canvas. So if you want to, like, if I went too fast or you need to go back and pause it. Go back and like work. I know I skipped through this kind of fast, guys, but go back and pause it and then work it out on your own paper. This is not a time to quit and be like, you know what? If I'll forever blame, not doing well on the AP exam because of coronavirus. That's not a time to do that. I don't think anybody in this lecture right now has that attitude, but I just want to encourage you to keep pushing on, keep driving forward. I know this stinks for your senior year, but again, I'm praying with you that I hope we go back on April 14th. And I don't know, I'm a person of good news. I'm not someone who wants to just, stick to all the negative news. When I read about, obviously China, they're kind of starting to function again. So I saw where Apple had reopened all 42 of its locations in China. So I think it's, again, we can see that we should be good if we stay isolated long enough. So stay on the up and the up, guys. I'm hopeful that we go back to school. I'm prayerful that we go back to school, not for my sake or more just for your sake. I don't want your senior year to end like that. So stay positive. Only positive, as you all would say, positive vibes. Don't mean to give you a speech right now, but I guess you guys kind of know who I am naturally. So just want to encourage you. Hey, don't find a routine, stick to it, do this work. I know you want to get out there and work and do other stuff, but hey, this is keep the main thing the main thing. So keep your priority there. Keep your relationship with God. Stay to it. Any questions of me? I'll shut up and get off that because I'm sure you've all been hearing that. What's the hint for the test? You would ask me that, Colton. The hint for the test is make sure you read the directions. Make sure you read the directions. If you don't read the directions, you will probably do more problems than what you have to. But may not be a bad thing. Questions of me? Any other questions of me? Talk to me. No, at least say no or something. No other hints. That's a pretty good hint because you don't have to do them all. I may send you a hint sometime. I may send you a little help guide. All right. You all have a good weekend. You guys know I love you. Miss you guys. It's not the same. Being there in person, where we can all give each other a hard time. So, not the same. Know that I love you, miss you. Stay up, stay prayerful, trust God in all this craziness. So, I may see you out if you're ever in the drive-thru at Chick-fil-A, throw the deuce at me. So, good day, everyone. You all have a good weekend. Be careful. I'll send a message on in Canvas about next week. So, good day, guys. Good day. Yes. See you guys.